Hello everyone, welcome back to yet another MrEncyclopedia Math Basics course where today inside geometry we're going to be talking about trigonometry. And so if you haven't watched the last triangle video, then I highly suggest you to do that, as it is a very great precursor to this trigonometry video, as trigonometry is essentially the geometry of right triangles. So please watch the other video before you watch this, and until then, stay tuned throughout this entire video as it is very important towards your math career. So thank you, and without further ado, let's get started. So first off, we gotta define what trigonometry actually is. Trigonometry is essentially the geometry of right triangles, otherwise known as 90-degree triangles. And as I've written over here. And now let's dive into a basic diagram of the structure of trigonometry, or trigonometric right triangles. So here we have a symbol called theta, and this is just a normal right triangle, and there's actually, just like I told before, there is no thing called trigonometric right triangles, as I've seen that before, but that is actually not a thing. It's just right triangles, but trigonometry is the subject. So yes, and here it's just a normal right triangle, only relies on or depends on normal right triangles. And here we have a symbol called theta. Theta is a placeholder in trigonometry, although that's not the actual definition of it. It's a placeholder in trigonometry, and it's a way to look at the relative side that we're talking about. And here there are three sides, so just like opposite, I just wrote it for opposite, and opposite side is always going to be opposite of theta. It's not going to be the opposite of the right triangle, but of theta. And so since the theta is pointing over there, this is the opposite side. Next is hypotenuse, and just like anywhere else or in any other right triangle, hypotenuse is always to the opposite of the right angle, always, like period. And then the adjacent side is the side that's close to the theta but is not the hypotenuse, so this side. Okay, and now let's talk about the definitions of each of the three major parts of trigonometry, and those are sine, cosine, and tangent. Sine, which we write for sin, is essentially opposite over hypotenuse. Cosine, which is COS abbreviated, is adjacent over hypotenuse, and tangent, which is TAN, is opposite over adjacent. Okay, now let's talk about the acronyms of each one so that you can memorize them clearly. So sine is opposite over adjacent, so here we have written SOHCAHTOA, so sine being opposite over adjacent, it's S and then OH to make sure you remember the order and what key part it's in. So, which is SOH, is sine, which is equivalent to opposite over adjacent. Ka in SOHCAHTOA is cosine, and it's adjacent over hypotenuse. And additionally, I think I may have made an error, it's sine is opposite over hypotenuse, now opposite over adjacent, and tangent is opposite over adjacent, not sine. So tangent is opposite over adjacent, and that is TOA, SOHCAHTOA. Here we have a symbol, and this is how you're actually supposed to write it. Don't just say sine of the triangle, as it is not really clear what you're talking about the sine of. It could be sine of one angle, it could be sine of this angle, but anytime if you're in trigonometry, you always refer to theta, so always say sine and then theta. You can put theta in parentheses or just like that, depends on how the teacher tells you to do, but make sure you listen to your teacher. But yeah, this is just an overview about the basics of trigonometry. But what's the point of learning all this, all these calculations, when you are actually not doing them? So let's go to an example problem. Let me just zoom out of there really quick. I can just on my way there. Okay. And yes, here it is, well, pretty basic, just like how we talked about in the previous one. So as we know, sine is or sine of theta, cosine of theta, and tangent of theta. Please don't forget to write the theta. Now here's an example triangle with the theta over here on the bottom right, the right angles on the bottom left. So obviously 10 is going to be the hypotenuse, 6 is going to be a leg, and 8 is going to be a leg, probably the longer leg. And here I've written the quadratic formula, and for those of you who don't know the quadratic formula, it's essentially saying a squared plus b squared is equivalent to c squared. A being one of the legs and B being the other leg, equivalent to C, which is hypotenuse, and hypotenuse is always longer, so essentially in theory the formula does make sense. But also, this is a popular triangle trio, or popular triangle triple, which is what we call triples that we can memorize according to patterns. And so 6, 8, 10, and we can also check it in the Pythagorean theorem to see if it's a right triangle, as Pythagorean theorem only applies to right triangles. So 6 should be A, so, or 8 could be A, but let's say 6 is A, which is one of the legs. As long as it's a leg, it's going to be either A or B. So 6 is A, so 6 squared is 36. 8 can be B, so 8 squared is 64. So now we have 36 plus 64, which equals 100. So C squared must equal 100, and since 10 is C, it's going to be 10 squared equivalent to 100, which is true because 10 squared is 100, so 100 equivalent to 100. So as we can see, it is a right triangle. And now we can use it for calculation. So sine of theta, which is, I told you, remember the placeholder. So essentially what I mean by placeholder, it's a way you can measure the relative side. So here it's going to be 3 over 5 because the opposite is 6 and the hypotenuse is 10. So 6 over 10 is equivalent to 3 over 5. Cosine of theta, it's going to be adjacent over hypotenuse, so adjacent is 8, hypotenuse is 10, and so it's going to be 8 over 10, or 4 over 5, simplified, and tangent of a theta is going to be opposite over adjacent, so opposite is 6, and adjacent is 8, so 6 over 8 is equivalent to 3 over 4. You can also write in ratios, so 3 to 5, 4 to 5, and 3 to 4, but fractions are more common. Okay, so now let's see here, we have another example. And this example is actually almost the inverse of what I just talked about. Usually you'll be asked to find what the sine of theta, cos of theta, or tan of theta is. But let's give you an example that they give you sine of theta. So you're like, well, how do I calculate the sine of theta? Well, if it's already given to me. But they may not be asking you to do that. They may give you the sine of theta. Let's say they say it's equivalent to 3 over 5, like we found over here. And let's say they give you the hypotenuse, or one other side of the triangle, and they ask you to find what the opposite side of that theta is. So you may be like, well, I don't have the other two sides, so I can't use the Pythagorean theorem to find it. And actually, it is relatively simple, because we just learned that sine is opposite over hypotenuse, and we have hypotenuse is equivalent to 5. So sine, which is 3 over 5, is equivalent to opposite over hypotenuse, which is 5. And since we're asked to find the opposite, it's going to be 3, because 3 over 5 is equivalent to opposite over 5, so opposite is equal to 3. And obviously we can find the other side using a combination of all of sine theta, cos theta, and tan theta. It just requires some calculations that you can use a calculator for if they expect you to find an actual decimal point. But yes, that is a pretty basic overview of trigonometry. I hope you enjoyed the video, and stay tuned for more math basic tutorials.